Okay, this video is going to cover part one of using units of measurement. Please complete your closed notes while you watch the video. You can just pause it when you need to. And here we go. So, using units of measurements is important. Take, for example, the NASA Mars Climate Orbiter. In 1999, this miscommunication about units of measurement had devastating consequences. There was a miscommunication that resulted in this miscalculation that caused the orbiter to go too close to Mars and disintegrate in the planet's atmosphere. This mathematical mistake cost $125 million and no data were collected. So what happened was one of the parts here in the orbiter was like manufactured in America, and the rest was manufactured in Europe, and they have a different system of measurement. They use like the metric system over there, and we use the American system. And so they calculated like inches where they should have calculated centimeters, and as a result, the thing blew up. So pause the video and discuss or respond on your note sheet what is a situation where clearly communication regarding measurements could be vital. So it became clear we have to always use a standardized system of measurements. And in 1960, scientists established the metric system, which is called the International System of Units, or the SI system. And it includes base units that describe physical quantities that have key importance in scientific units. I want to jump to the book for a minute so you can see the base units we use. And on my ebook, which is where I am and where you should be also reading, we can see that we have a base unit for mass, which is the G for grams, for length, which is M for meters, and volume is a capital L for liters. If I go to a bigger unit, I multiply by 10, and it goes up by powers of 10. Into bigger units, we get hecto and kilo. If we multiply by 100 or 1,000, or we get deci for dividing by 10, centi for dividing by 100, and milli for dividing by 1,000. So you can think of all those spots on a ruler that are really small. So all we do when we divide by 1,000, we go from a larger unit, a gram, to a smaller unit, a milligram. So we would move a decimal to the left 3 spots. And if I wanted to go from a larger unit and communicate that in terms of a smaller unit, I would multiply by whatever the designation of my prefix is. In this example, 5 kilograms is equal to 5,000 grams, because this decimal point after there is moved over 3 times. So let's go over some worked examples so you can practice how to write the correct quantities for each conversion here. So thinking of my base units, my decimal point is after the last 0. So 38 and the commas there. Point 0, right? So to go from a large unit like a kilogram, which is equal to 1,000 grams, to a smaller unit like a gram, we multiply. I want to see how many thousands of grams are in a kilogram. So let's multiply by 1,000. and I can do this without a calculator if I just think of moving the decimal 3 places. Pretty easy. And they would say it's equal to this many grams. And so now this is going from meters, which is like 3 feet, to millimeters, which is that smallest little line on the ruler. So a meter is how many thousands of millimeters. We would want to go from a larger unit to a smaller unit. So I would think 6.5 is how many thousands of millimeters. So I move the decimal 1, 2, 3 spots for 1,000. So I want you to memorize the values of, so it would be 6,000, sorry, it would be 6,500 millimeters. So I want you to memorize in your book what the prefixes are for 1,000, 100, and 10 as you go bigger and smaller. Deci, centi, milli. You should know that by memory. So now let's think of this one. Now we're thinking of a small unit like a milliliter, which in our cylinders that we use for toothpaste was that smallest little line to a liter. So I want to know, now I want to divide, and as I want to know what fraction thereof 4.3 is a liter. Since I have the lowercase m for milli, that means divide by 1,000. So 1, 2, 3 to the left, and then I put a 0 in each spot. So it's equal to 0 equal to, sorry, still getting used to this pen, 0.43 liters. Now, whenever you see a problem going from one base unit with a prefix to another base unit with a prefix, like from kilometers to centimeters, we want to do 2 conversions. First, we want to go to the base unit, which would be meters, and then into centimeters. So so how many meters would be this value of kilometers? We would have to multiply by 1,000. So move the decimal 1, 2, 3 spots to get, okay, and it would go here. So we have this is equal to 20 meters. 20 meters is equal to how many centimeters? Think of the decimal after that 0. And now we multiply to go from meters to centimeters. How many hundreds of centimeters are in a meter? Multiply 20 by 100. So I would say 20, and the decimal would go 1, 2 spots. So I would put the comma, and it's 2,000 centimeters. I'm going to stop this video here because it's long enough and give you a chance to reset. Watch the next video for the rest of your notes. And